So once we have established the conceptual model, in the next chapter of your thesis or in a research article, you have to show the methodology, the research methodology. So this starts actually with a description of the sample. So we can see here, for example, the sample we used about the acceptance of IoT, smart connected objects. So we had two samples with 344 people. You have to describe the distribution of the sample, 40% women, 60% men, mainly young people because it was a convenience sample. And we primed the respondents with a video with a scenario. That's important because we're talking about disruptive technology, so it's important to show the technology in action. Ideally, it would be done with a real technology. But if the technology does not exist, you need a video, a scenario, a written scenario, or even better, a video scenario. You can do it also with augmented or virtual reality, with simulators. Here, in this case, we did it with a video, and this is happening in most of research, actually. For this first study about smart homes, we did it actually also with a video, 5 minutes video, and then we surveyed again with a convenience sample, 300 people in France, Germany, and China. The sample is quite good, well distributed in terms of representativity, but it's not a representative sample. In sample 2, this is done within a DBA research project who did actually study about smart home adoption in Bangkok. 319 people in Thailand, mostly females, and actual users of smart homes. This is a real contribution of this in the domain, because if here we showed a video about a smart home, a scenario, here we surveyed people already living in a smart home, already having user experience, mostly of them for more than 2 years. So that's the main contribution also of this research, of this DBA thesis. In the case of autonomous cars, we did different surveys. First of all, we did a first study one in Germany, administered by a professional panel provider, which has the advantage of representativity of the German population. And we showed again, in order to make a framing, a video of 5 minutes showing an autonomous car of a level 5 cars. Then we did a second study, also in Germany, together with the university in Stuttgart, the DHBW, where actually we did a longitudinal study within subject study. So this means that in sample 2, so 131 people were surveyed before driving a level 2 car. Here is the car. They drove this car in Stuttgart over 45 minutes. So it's a standardized track where they drove in order to have comparability. So before driving, after driving, where they experience different driving situations, braking, acceleration, maintaining the trajectory, changing the lanes. So before driving, after driving, and we had a final with the same sample. So this is called within subject study, where actually the people were surveyed before driving, after driving, and after driving in a level 5 car. But as level 5 autonomous cars do not exist, we used the virtual reality car simulator without steering wheel and without accelerator and brake pedals, which is here. So actually a simulator. Perhaps I will show you first. So this is in what they experienced in the car. So without hands, the car is changing automatically the driving lane. So this is a level 3 car. So after that the responses were surveyed. Here again, it's when they change the lane. This is a simulator, virtual reality simulator, where you have actually a driving cockpit without instruments, without a steering wheel and without brakes. And then here in the simulator, actually it's working like that. The driver is driving and we have different incidents to simulate actually with virtual reality the driving situations and how it will be in a real level 5 autonomous car. So the same sample was surveyed before level 3, after level 3, and after level 5 simulating. And then we had, for some of them, we measured also with EEG, so the brain waves, and with the eye track camera, we measured also the vision of the car and where, if people really looked elsewhere during the driving experience. So that's for our study about autonomous cars. About the chatbots, we measured actually with a convenience sample, putting people in the simulation situation where they should use a flybot, which is actually a chatbot based on Facebook, in order to book a flight between Toulouse and Bangkok based on the best price criterion. It was a convenience sample, so again, not representative, but with the priming situation, we showed the customers how actually a chatbot would work. For the service robot study, we had also a video, which you can see here, showing actually a service robot at home, how it would work. Again, the idea is here to show people a disruptive technology, which is not really existing yet, in order to show what it can do, in order to show the benefits. Because after that, we administrated the survey to them in order to measure their perceptions. So this was done with a professional panel provider, so it's a representative population of France. And the delivery drone, it's a representative sample also with 3,000 people. Again, we showed a video about the delivery drone showing home delivery of food or of drugs. You have to do the choice how to measure your concept. So in most cases, you use existing measurement scales, which exist in the literature. And you have to do some psychometric measurement quality analysis, which is done through factor analysis, which we'll learn in your quantitative seminars. So we use existing scales. All the scales fulfilled satisfactory reliability and psychometric quality, namely the Cronbach alphas are higher than 0.7, the Euroscore rows are higher than 0.7, and the convergent validity is close to 1. Here are the different scales. So you can see the UTA-UT concepts, effort expectancy, performance expectancy, facilitating conditions, behavior intention to use, and social interest, comes from UTA-UT, Venkatesh and colleagues 2012. The well-being scales come from Dina and Chan, and scale which I developed with a colleague, Julian Klorek. Ethical concepts comes from a scale developed by Olsen and colleagues. So you see here the different sub-items, conceptualizing the scales, and actually we use Likert scales going from 1, do not agree at all, to 7, absolutely agree with the statement. We measured technology security, technology risk or fear, trust with existing scales. Again, you see here the items in detail. Privacy concerns comes from Hong and Tong 2013. Self-qual comes from Parasuraman with the different subdimensions of self-qual that you can see here. Innovativeness is also an existing scale, and word of mouth is also an existing scale that that we have found in literature. So the psychometrical qualities are satisfactory. The discriminant validity is also satisfactory. We can see here actually that the different concepts or scales are not very strongly correlated, indicating us a satisfactory discriminant validity, because if the discriminant validity is not good, we cannot apply existing structural equation modeling to measure and to test our hypothesis. So in summary, the methodology chapter should summarize your sample, the structure of the sample, how did you prime or frame the persons through a scenario or real usage situation, and you describe here your measurement instrument, your data, namely conceptualized through, in our case, existing literature-based measurement scales.